Okay, welcome. So here we are on, whoops, technical difficulty, sorry. The R3 homework. R3 is dealing with polynomials, and your first basic idea is the concept of multiplying polynomials. And what I like to tell my students is to think of this little mantra: sign, number, variable. So when you get into a lot of things that are going on, you don't get too caught up in the overwhelming nature of it and just attack it one piece at a time. So for example, if I had negative 8x squared y cubed, and that's being multiplied by 5x cubed y times negative 2 x, y, z. Well, there's a lot going on here, so instead of getting caught up in that, just worry about the sign first. So I have a negative times a positive times a negative. Now, in case you don't remember the rules or need to brush up on them, I like to use the analogy that, let's say you and I are voting on an amendment in a local election. Well, if you're voting yes and I'm voting yes, well, then we are in agreement, and that's a good thing. And if you're voting no, but I'm voting no, that's okay. We're still in agreement. Everything's hunky-dory. We're going to get along. But if I'm voting yes and you're voting no, or if I'm voting no and you're voting yes, either way, there is going to be disagreement, maybe even an argument or a heavy discussion, and that could be bad. So when there is agreement, it's positive. When there's disagreement, it's negative. So in this case, I have a negative times a positive, disagreement, negative, times another negative. Oh, that's good. That's positive. So my answer is going to be positive. Now I deal with the numbers. 8 times 5 is 40, and then times 2 is 80. Now I deal with my letters. Now remember, the rule is when you multiply variables, you keep the base and add the exponents. So I have x squared and x cubed. That's 2 plus 3 is 5. And even though we don't write it, this is really x to the 1 right here. And y to the 1 and z to the 1. So I have 2 plus 3 plus 1. That's x to the 6th. And y3, here we have a y1 and a y1. So that's 3, 4, 5. And z, at the very end, there's only 1. I don't have to put the 1. I can leave it just like that. And there's my answer. I kept the base and I added the exponents. Now, you may also have a situation, you have problems where you might have, let's say negative 2x cubed y divided by z cubed. And all of this is being squared. Well, this 2 is being sent to the little 1 that we don't have written there, the 3, the 1 that's not written here, and to this 3 down here. Now, the rule on this is when you take a power to a power, you actually multiply the exponents. So what I get is negative 2 squared. X, 3 times 2 is 6. Y, 1 times 2 is 2 over z, 3 times 2 is 6. And now the only thing I want to do is I want to simplify this. Negative 2 squared is 4. So I end up with 4x to the 6th, y squared, over z to the 6th. And that's my final answer. Now, if I would have something like this, where I have 5 x cubed y to the 7th over 10 x y to the 3rd. Technically what you do is let's make this x to the 5th. So in this case, technically what you do is you would subtract, and you would get 3 minus 5, which is negative 2. And you'd have a negative 2 on the bottom. Problem with that is, you'd have a negative 2 on the top. The problem with that is you can't have negative exponents. And we need to move them to the opposite place. So my analogy here is, if you're babysitting and you have kids upstairs that are being bratty and whiny and crying and negative, you might send them downstairs to their room. So for example, if I have x to the negative 4th, which is really over 1, I'm going to send them downstairs and get 1 over x to the 4th till they get positive. Consequently, if I had 1 over x to the negative 3, if they're downstairs, I'm going to send them upstairs till they get a positive attitude. And then once again, this could be written over 1. We just don't do that. So over here, technically I would do 3 minus 5 and get negative 2, but then move it downstairs. So the way I like to teach it is, just ask yourself the simple question: where do I have more x's? Well, I have more x's on the bottom. How many more? 2 more. Where do I have more y's? 7, 3. Oh, that's on top. 7 on top, 3 on the bottom. I have 4 more on the top. And then the numbers, people get confused. Just go back to the fraction 5 over 10. That reduces to 1 over 2. 5 is half of 10. 5 goes into 10 twice and 5 itself once. That's my final answer on a problem like so, like this. Okay, next idea. The distributive property, and along with addition and subtraction and so forth. So if I have 4 times 2 x squared minus 3x plus 4 minus 2 times 5x squared plus 8x minus 11. Well, there's a lot going on here, but first we got to deal with the distributive property. So I'm going to send this 4 here, here, and here. And again, sign number variable, positive, positive. 4 times 2 is 8. And the x squared just comes along. And then positive times a negative is negative. 4 times 3 is 12. And the x just tags along. And then positive 4 and positive 4 is going to give me positive 16. Now, I'm going to send this minus 2 in everywhere. And we got to pay attention that it's a minus 2. So I get minus 2 times 5 is negative 10. And the x squared just tags along. Minus 2 times 8x. Negative times positive is negative. 2 times 8 is 16. The x just tags along. And then, negative times negative is positive. 2 times 11 is 22. Now what I like to do is I like to organize with some kind of symbols my x's and so forth. So now I have 8x squared, take away 10x squared, that's negative 2x squared. I have negative 12x minus 16x, that's negative 28x. And then I have 16 plus 22, that's plus 38. And that is my complete simplified answer. Okay, next we have the idea of multiplying polynomials. When it's 2 by 2, we have the acronym FOIL. And that stands for first, outer, inner, last. So if I have 2x minus 3 times 4x plus 5, I'm going to do the first times the first, which again is 8x Don't forget that's going to be squared, because that's 1, that's a 1. And I do the outside. 2x times 5 is 10x. Then I do the inside. And I get negative times positive, negative. 3 times 4 is 12, and the x just tags along. And then I do last. And I get negative 15. And I get a little smiling football head looking character. I'm going to join my inside terms. My o and my I are going to come together. And I'm going to get 8x squared minus 2x minus 15. And that is that polynomial, which is a product of the 2 by 2 polynomials. Now, if we're going back the other way, I do have a video online on the YouTube channel called Factoring Polynomials, and it's a nice, easy method on how to go from this to this. Okay. Now, that's a regular 2 by 2. We also have special situations where 2x plus 3 times 2x minus 3. Everything is exactly the same in each, except one's positive, one's negative. Well, what happens is, watch. I do my first times first, and I get 4x squared. I do my outside, and I get negative 6x. I do my inside, and I get positive 6x. And I do my last, and I get negative 9. Well, notice what happens here. My o and my I cancel each other out, and I'm just left with f and L. This is called the difference of two squares. Perfect square, perfect square, perfect square, difference, subtraction. So you're always going to get this situation when the parentheses are exactly the same, but one's plus and one's minus. Now, if you have this situation, and it can be written either way, 4x plus 5 times 4x plus 5. Here, you cannot just do the f and the L, because these are not going to cancel out. In fact, you're going to get double the same thing. 5 times 4 is going to be 20x and 20x. So your inside and outside terms actually repeat. It can also be written like this, in parentheses, and just squared, which means 2 of itself. Now, I want to show you a shortcut. You can do first times first and get 16x squared. And then your outer, like we said, is going to be 20x. And your inner, which is going to be another 20x. And then your last, which is 25. And notice this is going to be 40x, so you get 16x squared plus 40x plus 25. This is called a perfect square trinomial, because you're squaring the same thing, and everything in here is perfect squares, well, at least on the first and the last. So watch what happens. Here's a shortcut. You can also just square the first term, 4x times 4x, you get 16x squared. You can square the last term and put 25 over here. And then all you do is multiply here and double. 5 times 4 is 20, double 40x. And we get the same answer, just in a little bit time-saving mode. Not a lot, but a little bit. Okay. Last, dividing. This one can kind of be a pain sometimes. So let's walk through it. And I'll go through the example in the book. We have 2x minus 1. I just like using x's. And that's being divided into 4x squared, cubed, minus 8x squared, plus 5x, plus 6. Okay, so you look at the first term, here and here, and say, how many of these go into here? Okay, well, that's 2. 4 divided by 2 is 2. And then you have to look at the variables. x3, x1, well, that's going to be x2. 3 minus 1 is 2. And now you're going to multiply. And when you do that, you get 4x squared, sorry, 4x cubed here, minus 2x squared. And just like regular long division, we're going to divide, then we multiply. Now we're going to subtract. And these cancel right here. Negative 8 minus 2 is negative 10 x squared. And then we bring down plus 5x. And then we just repeat. How many times does 2 go into 5? I mean into 10? Oh, sorry, my mistake. I wasn't paying attention myself. This negative has to be distributed. So negative 4, which makes 0, but this makes positive 2. So this right here is actually going to be I do apologize. That's why I put this in parentheses for a reason. You're going to distribute the negative. So this is going to make this negative 6x squared. So how many times is 2 going to 6? 3 times. But we're dividing a negative 6. So we're going to do minus 3. The reason we're doing this is because we're going to subtract. And so when we subtract, we want this to be the opposite. So we keep that same sign. So, and we have x squared, we have x, so that's going to be 1x here. Now we're going to multiply. Negative 3 times 2, I forgot to bring down again. So negative 3 times 2 is negative 6x squared plus 3. Now, I'm going to subtract, but I need to put this in parentheses. So when I subtract, this is going to become positive 6x, and this is going to become negative. I forgot my x there, sorry. So, this cancels, I end up with 0, and I end up with 5x plus 3x, or minus 3x here, and that's going to be 2x. Bring down the 6. How many times is 2 going to 2? That's going to be plus 1. And I'm going to put 2x minus 1 here. Again, I can put in parentheses, or I can just do this. I can add the opposite of everything. That's another way, a trick to do it. So I get 0 there, and then 6 plus 1 is 7. And that's my remainder. So I write the remainder as 7 over 2x minus 1. Now it may seem kind of strange, but if you think about back to grade school, 7 into 15 goes 2 times, 14, subtract 1. When you're younger, you learn this, remainder 1. Then when you're older, you learn to put this over the 7, and you learn to write it as 2 and 1/7, which is technically 2 plus 1/7. So that's how you do long division of polynomials.